Hey everybody, and welcome to the Law of Sines video. This is video 2. The last video was Law of Sines, the angle side case. This is going to be the case that we have a side, and angle given to us, which case we can still use Law of Sines, but there's a couple things that we're going to have to account for, and that's why this is going to be called the ambiguous case. So let's look. So what is the ambiguous case? What does that mean? The law of sines is great when we're given angle, side, right? We saw that in the last video. We solve for a missing side, missing angle, whatever we need, and we go on our merry way. But when we were giving side, angle, or the SSA case, things get a little ambiguous. There could be 0 triangles, 1 triangle, or 2 triangles that match this particular description. In other words, with the information given, there's a little bit too much wiggle room, and it's not rigid. It's not like, hey, well, here's the missing side. It's like, well, this could be the missing side, or this could be the missing side, or this could be the missing angle. So for instance, if little a is 54, little b is 62, and big A is 40, we actually have 2 triangles that can match this particular description. If you look, little a is 54 in both cases, little b is 62 in both cases, and big A is 40 in both cases. But there's 2 valid triangles that have this description. In one, C is 92 and the other is 8. In one, B is 48 and the other, B is 132. But there's 2 triangles that match this description. So we're going to try to figure out how to distinguish if we have 0 triangles, 1 triangle, or 2 triangles while using law of sines and only given side, angle descriptions. So the first example we're going to do is where there's no triangles valid for this. So let's see what that looks like if we have no triangles. So in this example, A is 2, B is 6, little b, excuse me, is 6, and big A is 30, which is the angle. Well, let's do law of sines. So we go across. So little a over sine of big A equals little b over sine of big B. Okay, cross multiply. 2 times sine of b is equal to 6 times sine of 30. Divide both sides by 2, divide by 2, divide by 2. And we get sine of b is equal to 6 times sine of 30 over 2. Let's hit this with the inverse sine on both sides. So we're going to take inverse sine of what you see in red. So what that is then, so b will drop out on the left because sine and inverse sine undo each other. On the right, we would get sine inverse of, and then this is all going to amount to 1.5. And now here we would have an issue. So if you put this into your calculator, you would get an error. So why do we get an error? Well, because remember, sine inverse is saying, okay, sine of this angle will evaluate to this number. But if you think to the unit circle, right, sine is only ever between, at its highest, +1, at its lowest, -1, right? There's no other sine values on the unit circle. Everything is between -1 or +1. Therefore, to try to take sine inverse of something that is outside that domain is an error. It doesn't exist. So I can't take inverse sine of this number because it's outside my domain of sine. Sine only lives between -1 and 1. If you ever try to take inverse sine of numbers outside of that domain, you'll get an error. It doesn't exist. So therefore we get an error, which is why this triangle cannot possibly exist. At the end of the video, we'll see some rules of thumbs that you can see, oh, right off the bat, this would be a no triangles, 1 triangle, or 2 triangle case, okay? But for now, work it all out. If you get an error when you hit your inverse sine, this is a no triangle example. This thing can't be. So that was the 0 triangle case. Let's look at now where we know that there's absolutely 1 triangle where this description will match. Let's write in red this time so we can actually see it. So big C, 35.4, 35.4, little a, 205, and little c, 314. Okay, law of sines, little c over sine of big C, just sine of 35.4 equals little a over, if we go across, sine of big A. Okay, so cross multiply again, 205 times sine of 35.4 is equal to 314 sine of A. Divide both sides by 314, divide by 314, and we would get sine of A is equal to, see if I have it in here. Let's see, so that's 205 times sine of 35.4 divided by 314, and that gives us 0.378. So if I hit that with inverse sine on both sides, and that's between -1 and 1, so I know I'll actually get a valid number. So then A would be equal to, and I'm going to round it to the nearest tenth, so it's 22.2. Okay, so one value for A could be 22.2. Here's how you can see if there is another value. So it's whatever value you get, if it's valid, right? In the zero triangle case, we got to this far and it was an error. Well, that's right away, well, there's no triangles. So the other way is you subtract it from 180. So 180 minus 22.2, that's 157.8. And now you see, is that a valid angle? Well, 22.2 works, right? Because 22.2 plus 35.4, this angle would be something else, but we can get 3 angles that would add to 180 and everything's totally fine. But if A was 157.8, well, 157.8 plus 35.4, that's already bigger than 180. So there's no room to even have a third angle here. So this just can't be. So when we subtract our original answer from 180, we get something that doesn't make sense because our other angle is 35.4. So if we had 157.8 plus 35.4, that's bigger than 180, and that violates the fact that a triangle has to equal 180 degrees, the interior angles. So this second case can't be. So therefore, there is only one case here that can make this true. So this is the one triangle case. But all this goes to show is you have to check. So when you do your law of sines and you get your missing angle in the SSA case, subtract it from 180 and see if what you get also makes sense. If it doesn't, then cross it out. This is a one triangle case. If it does make sense, then we'll see in the next example what to do with that. Okay, so let's look at a two triangle case now. And this is the one that we saw at the very beginning. It's the same example. So A is 54. We're just going to work it out now. B is 62. And big A is 40. Okay, let's law of sines it. Little a over sine of big A equals little b over sine of big B. Okay, cross multiply. 62 times sine of 40 equals 54 times sine of B. Divide everybody by 54. Get rid of those guys. 54. Okay, sine of B then is equal to, let's do 62 times sine of 40 over 54. 62 sine of 40 divided by 54. 0.738. Okay, is that between -1 and 1? Yes, it is, which means we can inverse it and be totally fine. So let's inverse sine both sides. Inverse sine both sides. And we get that B is potentially sine inverse of that thing is 47.5. My degrees right now are in nice whole numbers, so I'm going to round off. So this would be 48. Or 180 minus 48 So, or 132. So the question is, well, does that 132 also make sense? Would that be a valid angle for B? So B can either be 48 or 132. Does that work? Well, let's look here because this is already drawn out here. So if B is 48, right, that was one of our options, that's cool because then C could be 92 and everybody lives in perfect 180-degree harmony. So that's cool. And that would make this opposite side here 84. Fine. Okay. Can B be 132? Yes, it can, because that just builds this different triangle. All that means is that the angle for C would have to be 8 degrees, which is totally fine. And little c down here would be 12. So both of these angles work. So you test 48. You put it 48 in your triangle. Be like, okay, well, 40 plus 48 plus, okay, then 92. Okay, that's a 180-degree triangle. Okay, that's totally fine. That works. Great. And then you test 132. Okay, well, 40 plus 132, that's just 172. Okay, great. Well, there's room for C. C would just have to be 8 degrees. And I guess, yeah, that works as well. So that is why both of these work. So B can be 48. B can also be 132, which is why this is indeed the two triangle example. So again, to reiterate, play your regular law of sines game. Get something for your missing angle. And again, this is for the SSA case. Then subtract it from 180. When you subtract it from 180, does that value also make sense? Is that a value that I could plug into my triangle and have 3 valid angles that equal 180? Yes? Great. Then you're in the two triangle case. So now let's look at some rules of thumb. So in the triangles that I've been working with, the little h here is the height. Okay, so if you want to take down this diagram, it might be a way for you to kind of shortcut just to see what case you're in. Am I in a 0 triangle case? Am I in a 1 triangle case? Am I in a 2 triangle case? You can see there's only one condition here that would get us in a 2 triangle case. 2 for 0 and 3 for 1. All right, so again, if you want to take this down, and again, h is the height of the triangle. So h is the height. So when you see the h's in here, the h is the height or the altitude of the triangle. Okay? So I hope that was informative. I hope you guys enjoyed it. We now know that we can do law of sines in the angle-angle side case. We can also do it in the side-side angle case. We just need to check, hey, because this is the ambiguous case, does this mean there's 0 triangles with this description, 1 triangle with this description, or 2 triangles with this description? All right. As always, if you guys have any questions, please don't hesitate to ask.